Hello everyone, I hope you guys are doing well. Welcome to another Linux video. So in our last video, file permission management part 1, we discussed about the file permission and how to change the permission using chmod command. And I promised to come up with the part 2 video and include a few more commands to deal with managing file permission in Linux. So we'll start today's video with the continuation of chmod command that we left the last time and see a few more uses of that command. And then we'll move into changing the ownership of files and directories later. So if you followed our last video closely, which I'll also link on the top right corner of this video, it should appear anytime now. You would notice that the file permission is represented by read, write, and execute symbol, RW and X for short. And those permissions can be changed by using chmod command, which we saw in the last video. So when you type ls-l or ll in short, you will see that a lot of properties of files and directories are displayed. And we discussed about this first column, which will give you the file permission. And we also said that the first bit out of 10 bits, it'll tell us what kind of file we're dealing with. So D is directory. If there's nothing, it's a plain file. L is link file. B is block device. C is character device, etc. And this 3 will represent the file permission for the user. In this case, Umesh is the user, and Umesh is the group owner of the file. And these 3 will represent the permission for this group owner, and the rest 3 is for others, which is not the owner of the file or the member of the owner group. So read, write, execute, read, execute, read, execute. So 7, 5, and 5 in numerical representation. So we discussed that, and we also saw how to change this permission using chmod command. And today we'll discuss about SetUID, SetGID, and sticky bits in Linux file permission. So let's start with SetUID. And SetUID bit, also known as SetUserID bit, is normally applied to the executable files. And if the file has a SetUID bit present, it will execute with the permission of the owner of the file rather than the permission of the user who executes it. And when the SetUID bit is applied, it appears where you normally see the executable permission, X permission on the file. And the symbol for SUID, SetUserID, is a S. So let's create one file, test UID. So default 664. And the command is chmod u plus testuid.txt. So this is set user ID on the user, obviously, and test uid.txt is the name of the file. You'll notice that there's a letter S now, and that means set UID bit is present. But you see this uppercase S, and normally you will see lowercase s because it will be applied to the executable file. And since there is no executable permission in this file, you will see that set UID is represented by upper S. But if we go and change 764 test UID, now this file will be executable file. chmod u SetUID test. Now a special permission is applied, SetUID, for the user, and it is represented by the lowercase s. So lowercase s means there is an executable permission and SetUID permission, and uppercase means there is no executable permission present, only SetUID is enabled. Let's clear the screen. So you might wonder, what is the use of this SetUID bit? So what happens is oftentimes when the command is executed, it needs to be executed with a special privilege to serve its purpose. For example, when you change, as a normal user, when you change your password using passwd command, it will update the new password information into shadow file. So this is my current password, salted password. And when I change the password using passwd command, the system will update this database and write the new password in this file. But if you look at the permission of this file, it only has read-write access for the root and read access for the shadow group, and no permission is set for other users. So if I go and check who are the member of that shadow group, nobody. So basically only root is allowed to change this file. But the question is how normal user update their password if they cannot write into this file, right? So that's where this special SetUID bit permission comes handy. So what happens is if you look for this command, it is actually inside /usr/bin and passwd. So if you do /usr and bin, so if you look at this command, passwd command, it has read, write, execute, and SetUID bit present, and read and execute for group, and read and execute for other users. So everyone can execute this command, but only root has permission to read, write, and execute the file with the SetUID bit present. So that means when a non-root user issues passwd command to change the file, the system will treat as if it is executed by the root. And since root has read-write permission on the command and ultimately in the shadow file, it will change the password and update the new password into etc shadow file. So basically, when you run the command or program that has a SUID bit set, you actually inherit the permission of the program owner, and the program is run with that permission. Otherwise, if no SUID is set, it will just run with the permission of the user who is executing the program. It is as simple as that. And we saw the example where this is handy. So I'll change the password, and there are a lot of other system commands that you might need root privilege to execute the command and get the things done. So we saw how we change the permission and enable SUID bit. We saw the alphabetical methods, chmod, user, SetUID bit, and test file. And let's remove the permission. So now SUID permission is removed. We can also use numerical method on which we'll calculate the existing permission 765 test UID. Now we are going to add number in front of that permission, which will be for the SetUID. So 4 is for SetUID bit. And if you do the same command, oops, looks like I added execute permission for other users too. It should have been 764 because there was no execute permission in the first place, my mistake. And now it's the same permission as if here, but with the SetUID bit enabled. And to remove the permission using numerical method, you simply put 0 here, and SetUID bit is gone. As you can see, SetUID is very useful, but needs to be very careful when giving this permission to the file. Usually hackers and pen testers, they look for such a file to elevate their access to the system and try to exploit it. So this is useful, but you just have to be careful while assigning the SetUID to any executable file. Okay, our next is SetGID. It's similar to SetUID, but SetUID is for user and SetGID is for group ID, set group ID. So let's look at that one. SetGID, it affects both files as well as the directories. If you run a program with SGID enabled, you will be running the program with the permission of the group owner of the program rather than your group permission to the program. And when the bit is set for a directory, the set of files that are created inside that directory after the bit is set will have the same group as the group of the parent directory and not that of the user who created those files, if that makes sense. I'll show you an example later, and that will probably clear things a little bit more. It is very useful for file sharing or collaboration purpose. Let's say you create a directory and you apply SetGID on that directory. And if a user creates a file inside that directory, all the files will inherit the group permission of that parent directory. And now it can be accessed by the other members of that group as well, and will have the same level of access as a group of that directory, parent directory. Let's try one example. It's a little confusing, but let's make it a little clear. Okay, let's create one directory, SetGID test, and let's create one file inside that directory, and create one directory, test2. Now, if I switch user, I create one user, guest user, and go to my home folder, SetUID. Actually, let's do this first. Permission. So the file that I created, test1, and the directory test2 has Umesh as the owner of the file, and Umesh group is the owner of the file. So if you create a file inside that directory, now let's go inside that folder. So I'm still guest user. Let's create one file, test3, and create directory test4. Okay, permission is denied because other user do not have write permission on the file. Okay, let's fix that first. Let's open another terminal. Do chmod. Let's do 777. Now let's try to create that file again. Okay, successful. So you will see that the file that I created from user Umesh has Umesh user as a owner of the file, and Umesh group is the owner of the file. And when we create test3 and test4 files by the guest user, the file is owned by guest user and guest user group. But let's see what happens. Let's exit out. Now I'm Umesh and enable SetGID. And for that, we'll do chmod g plus s for the group SetGID and that folder. And you can see the SetGID bit present where the executable permission is present on the group, lowercase s. Now let's log into guest user. Go to my home directory and go to that folder. Now let's create 2 more files and see what will be the new permission for those files. Test4. So create 1 file and create 1 directory. Oh, yeah, I cannot do that. Linux is case sensitive. So if I do ll now, you'll notice that these test5 and test6 are those files that we created after GID bit is set, group ID bit is set. And the owner of the file is guest user, which is the user I'm currently logged in and created those files. But Umesh is the group owner of the file. And it's because this directory, SetGID test directory, was created by user Umesh and it had a GID bit set. So whenever you create any new files under that directory, the group permission of that file that you create would be the group owner of this parent directory. In that case, since SetGID test was created by user Umesh, it automatically got Umesh as a group owner of the directory. And any file that you create inside this directory will have Umesh as a group owner of the file. Does it make sense? I hope it does. If you practice, just create a folder and log in from another user and try to create a folder and see what will be the owner and the group owner of the file. And then come back to the previous user, set GID on that directory, and then go back to another user again and create a file, and you'll see the difference. The owner of the file will be the owner who created the file, but the group owner would be the group of the parent directory where the GID bit is set. Let's log out. And you can also do chmod g. Now remove that permission. It's now read-write executable only. And similarly, like we did on SetUID, you can use numerical method. And for that, chmod. So 4 was for SetUID, and now 2 is for SetGID. And the existing permission is 777 SetGID. Now it has SetGID bit. And the third special bit is called the sticky bit. And sticky bit is, in case of individual files, a sticky bit has no useful meaning, at least in modern operating system. But when a directory has a sticky bit set, the file system treats the files inside such a directory in a special way so that only the owner of the file, owner of the directory, or the super user, which is root user, can delete or rename the files inside that directory. Without sticky bit present, any user with the write and execute permission to the directory can rename and delete the files inside the directory, regardless who owns the file and directory. Let's look at the example. Let's create 1 folder, set sticky bit, and give read-write permission to everyone. So it has read, write, and execute permission to everyone. Now let's log into our guest user. Actually, let's create some files there. That's test1, and let's also create now login. So it was created by user Umesh, and group owner of the file is also Umesh. So remove test1. So it is giving me warning, do you want to remove this file? I say yes. File is gone. And that is also gone. So it was owned by user Umes and group Umes, but since this directory had read-write access permission to other users as well, and in this case, guest user is the other user because this user is not user Umes and is not a member of group Umes, which you can see here. So Umes has no member. It was able to delete those files. Now let's go back. And nothing there, it deleted by the user. First, let's set the sticky bit. And to do that, the command is chmod plus t. There is no u or group. Set sticky bit. Now this the t represents the sticky bit is enabled, and you can see that in the other user's permission. And now let's go and create those files inside that folder where sticky bit is enabled. Test1 and also test2. Okay, so same permission as before, as we see here. Before sticky bit was enabled, same permission to the file, but now let's switch to the guest user. Guest, who am I? I'm the guest user. Yes, set sticky bit user. Now let's try to delete the file and folder again like we did the last time. Remove test1. It is still giving us a warning that you want to delete this file, and you will say yes like we did last time. Operation not permitted, because the parent directory where the file is sitting has a sticky bit enabled. And the same thing. Operation not permitted, because same thing, the parent directory has a sticky bit enabled. Very popular use of sticky bit is inside this directory /tmp, where all the temporary log files and temporary files will be stored for all the users. So it has sticky bit enabled so that no ordinary user can delete the files created by other users, and deletion permission is reserved only for the owner of the files. Now let's go back and see how we can remove the permission. So we'll do chmod -t, remove the sticky bit permission. This will be gone now. And if we want to use numerical method, chmod for sticky bit number 1. So for SUID 4, SetGID 2, and sticky bit 1. And the existing permission is 777 for file. Now it will have a sticky bit permission enabled. And to remove using numerical method, simply 0. And it'll be gone. So that will be pretty much it for the chmod command. And now let's move into changing the ownership of files and directories, user owner and the group owner of the file. When you create a user in Linux system, it'll create a user as well as a group for the user, and will be given a unique ID for both user and the group, which we call a user ID and group ID, or UID or GID in short. By default, those automatically assigned UIDs and GIDs will start from number 1000. So if you go and check /wd file, and Umes is the user I created after I installed the system. So Umes has UID 1000 and GID 1000. And guest user, which I created for this video, has UID 1001 and GID 1001. Usually, just to make things simple, UID and GID will be the same number. So any number below 1000 is reserved for the system use, which it will assign to the system accounts, services, and other special accounts. If you look at this file, you will see that 0, 1, 2, 3. So these are system accounts. And as you can see, the root user always have UID and GID of 0. Our system separates the power and gives special privilege to root user based on that IDs and not on the basis of the name of the user, which is the root. Actually, system sees this UID and GID and says, oh, this user has a UID of 0 and GID of 0, so it must be the root user, and give a special privilege to this user. Normally, whoever creates the file or resources, that user would be the owner of the file or resources, and the primary group of the user would be the group owner as well. So if in case you need to change the owner of the file, you can use command chown, change ownership, and the syntax would be chown and the new user and file name of which you want to change the ownership. Or you can also do new user UID here instead of a new username. So let's look at the command. So test has Umesh as the owner and Umesh is the group owner. So if you do chown guest user, which is the user that I created, and test, operation not permitted. And the reason is, even if you own this file, even if I own this file, as a normal user, I cannot change the permission of the file. It's weird, isn't it? You own the file, but you cannot change the ownership of the file. It's because only root user, super user, or the sudo user can change the permission of the file. So if you do same command with sudo my password, now the owner of the file is changed to guest user. If you're wondering about this command, you will actually run the last command with the sudo permission, sudo and this 2 exclamation. We'll just repeat the last command. I talked about this command in one of the video I created for Linux history. I'll put the link on the top if you're interested to look at that video. And if you want to change the group owner of the file, you can still use chown command and to change the group colon and the name of the group, or you can use the group ID, which is 1001 for guest user and test file. So now guest user is the new owner and guest user is the new group owner of the file. And you can use chown command to change the owner of the file and group owner at the same time by doing umesh umesh test. So here we're changing it back to umesh, and this is the new owner of the file and this is the new group owner of the file. Back to umesh. So you can use chown command user group and the name of the file. If you only want to do the group, then leave this blank, colon and new group. And if you want to do both, just do this. But there's also another dedicated command just to change the group ownership of the file. And the command is chgrp, short for change group. So the command is similar, new group name and file name. So sudo group guest user test and change to guest user from umesh. Similarly, come back and change it to umesh. And you might also be able to do this. So you can use either group name or group ID. Same thing. So 1000 is for umesh. Back to umesh. So these are the use case of commands chmod, chown, and chgrp. You can use chmod to change the permission of the file or to set special permission on the file like SetUID, SetGID, or the stick bit. And you can use chown to change the user owner of the file or the group owner of the file. And the command chgrp you can use to change the group owner of the file. So with these 3 commands, I'm going to end this chapter of file permission management, but we'll come up with another video where we'll be discussing more useful commands for those who are just trying out Linux and those who are beginner Linux user and want to explore more. So tune in, and if you have not subscribed, please do so that you will be notified with the new videos as soon as I upload it. And thanks for watching the video, and I'll see you in the next video. Take care.